Okay, in this video, we're going to be taking a look at some SAT questions that you'll see on the test. They will be multiple choice, but for this review, I'm just kind of going over a little bit of what the questions look like, okay? So on number one here, it wants you to, or basically I just put write the equivalent of x to the 3/4 as a radical. So this is just a reminder, and it is a question very similar to SAT. So with the fractional exponent, the denominator of the fraction becomes the root power. And then the numerator of the fraction is the power under the radical. So it's the fourth root of x to the third. All right, let's take a look at number two here. This just says, what is the sum of the following polynomials? They may be lined up like this. Sum just means to add them or put them together. It's the solution to an addition problem. So really all you're doing is looking for like terms. These could be written horizontally or vertically, but you see you have a 3x squared and a 5x squared, which is 8x squared. And then a positive 5x minus 8x is negative 3x, and then negative 5 plus 7 is plus 2. All right, now let's look at question 3. All right, this one says, if you have the equation 2x equals 12, what is the value of 3x plus 5? So we're going to use the first equation to solve for x, 2x plus 12. That means x is 6. Then we plug 6 into the second, or into the expression 3x plus 5. 6 times 3 is 18, and 18 plus 5 is 23. So that would be one of the multiple choice answers. All right, now question 4. If 2/3 x equals 3/5, what is the value of x? So here I've written it where you can see it a little better. 2 over 3x equals 3/5. Now there are different ways to solve this equation. We could get rid of the denominator 3 and 5 by making it a common denominator of 15. Or if x is being multiplied by 2/3, the inverse is to divide by 2/3. So you're dividing both sides of the equation by the fraction 2/3. So to solve for x, then, you have to do 3/5 divided by 2/3. The way you divide those fractions, you do the first fraction, 3/5 times the reciprocal, which is 3 over 2, and then just multiply straight across. 3 times 3 is 9, 5 times 2 is 10, and your answer is 9/10. All right, let's take a look at number 5. This one just says, if you have a function, if a function has 3 zeros, create a graph that could represent the function. And again, it'll be a multiple choice, so you'll see 4 options. I just wanted to remind you that when you see the word zeros in a function, based on the graph, the zeros is where the graph crosses the x-axis. So this one would have 3 zeros. If you have a question about 4 zeros or 6 zeros or whatever, you're looking for the zeros is the number of times it crosses the x-axis. All right, number 6. Which expression, write an expression that is equivalent to the sum of the expressions x squared minus 7 and x plus 7. So we're just adding these two expressions. Here I've written them separately in parentheses, but really you just write it out. It's x squared minus 7 plus x plus 7. The minus 7 and plus 7 in this one will actually cancel out, and you're left with x squared and x. You just write that out, x squared plus x. We can't combine those because they have different exponents. They're not on the same team, if you will. All right, number 7, what are the solutions of the quadratic equation 4x squared minus 4x plus 24? Okay, basically we're going to solve this like it is an equation. We're going to set it equal to 0, but the first thing that I did, I noticed that each term of this quadratic is divisible by 4. So I factored out the 4, and then what was left, we have x squared minus x minus 6, because if you multiply these terms times 4, you get back to the original. Well, now we have these two factors. We set them equal to 0. Of course, 4 doesn't equal to 0, so that's out. We don't have to worry about that. But the x squared minus x minus 6, we set that equal to 0, all right? Well, to solve this, what we're going to do is we're going to factor this part right here. That's where we use our x puzzle. So the factors of a times c, that's 1 times negative 6. the factors of -6 that equal -1, which is the B. Well, that would be 3 times 2 is equal to 6. One of them has to be negative, and it's going to be a -3 because -3 plus 2 is -1. So these are our factors, x minus 3 times x plus 2. But again, we're setting that equal to 0 because we're looking for solutions. Well, x minus 3, if that equals 0, then x is going to be 3. And if x plus 2 equals 0, then x equals -2. And that's your two solutions. All right, number 8. Write the equivalent of 25 to the 3/4. Okay, so this one is a bit challenging. We have a fractional exponent of 3/4, so y'all know that's the 4th root of 25 to the 3rd. Okay, but what I'm going to do, 25 is actually a perfect square, so it would be 5 squared. So another way to think of that is 5 squared times 5 squared times 5 squared, because this 25 is cubed. So we represent 25 with the 5 squared, and we multiply it times itself 3 times. Well, then if I factor 5 squared, of course, that's 5 times 5 each time. And I see these 4, this repeats itself 4 times. So this is one way of doing it, where we factor it all the way down to its prime factors. But these 4 come out as a single. And then what's left is the 4th root of 5 squared. Well, we don't actually stop there, because if you think about it, well, 5 squared, that's 5 times 5, but we could actually think of 5 as the factors of the square root 5 times the square root of 5, because that equals 5. But then we have another 5, so square root 5 times square root 5. So all 4 of these, if you multiply them, you're going to get 25, which is 5 squared. So this comes outside as well. Now, it looks like it's still inside, but it's because what we took out was the square root of 5. So that's one way to think about it. The answer is 5 square root 5. Here, I just rewrote it where I changed the 25 to 5 squared to the 3/4. Kind of, we get the same thing. But that's one way. This is one way to think about factoring that problem, or I'm sorry, simplifying that problem. Okay, now we're going to take a look at number 9. This says, what is the sum of the complex numbers 5 plus 6i and 7 plus 11i, where I is equal to the square root of -1? Okay, well, all we really have here is 5 plus 6i and 7 plus 6i. These are complex numbers. But we can just consider our like terms. We have a 5 and a 7. But if you're adding those, that's 12. And then you have a 6i and an 11i. 6i plus 11i. Well, those are the same terms, like terms. And 6 plus 7 is 17. So it's 12 plus 17i. That would be how you represent the sum of that expression. All right, and finally, number 10. Simplify the following expression. 3x squared minus 5 in a set of parentheses minus, and then in this parentheses, -5x squared plus 2x minus 8. Okay, I've rewritten it without the parentheses, because what I've done is I've distributed this negative to all 3 of these terms. So minus -5x squared became plus 5x squared. Minus positive 2x, I wrote minus 2x. And minus -8 becomes plus 8. Then I start looking for my like terms. Of course, the x squared, we have a 3 and a 5. That's 8x squared. Then I have, my next term would be x to the 1 power. So minus 2x, that's the only one, so minus 2x. And then my constants, I have a -5 and an 8. And -5 plus 8 is 3. So this would be how you would simplify that expression. All right, that is a quick review of some SAT type questions that you will see on this Unit 4 test about radicals and fractional exponents.